Understanding your brain to help you learn better. What happens in my brain when I am learning? Your brain is primarily composed of about 85 billion neurons, which is more than the number of stars you can see with the naked eye in the night sky. A neuron is a cell which acts as a messenger, sending information in the form of nerve impulses, like electrical signals, to other neurons. For example, when you are writing, some neurons in your brain send the move fingers message to other neurons, and this message then travels through the nerves, like cables, all the way to your fingers. The electrical signals that are communicated from one neuron to another are therefore what allows you to do everything you do: write, think, see, jump, talk, compute, and so on. Each neuron can be connected with up to 10,000 other neurons, leading to a large number of connections in your brain, which looks like a very dense spider web. When you are learning, important changes take place in your brain, including the creation of new connections between your neurons. This phenomenon is called neuroplasticity. The more you practice, the stronger these connections become. As your connections strengthen, the messages, nerve impulses, are transmitted increasingly faster, making them more efficient. That is how you become better at anything you learn, whether it is playing football, reading, drawing, etc. We can compare the connections between your neurons to trails in a forest. Walking through a forest without a trail is difficult, because you have to compact and push the vegetation and branches out of the way to carve your way through. But the more you use the same trail, the easier and more practicable it becomes. Conversely, when you stop using the trail, the vegetation grows back, and the trail slowly disappears. This is very similar to what happens in your brain. When you stop practicing something, the connections between your neurons weaken and can ultimately be dismantled or pruned. That is why it may seem so difficult to start reading again when school starts if you have not read all summer. However, it is possible for some neural networks to become so strong that the trails or connections never completely disappear. The fact that learning rewires your neurons shows how dynamic, plastic, your brain is, that the brain changes and does not remain fixed. Practicing or rehearsing repeatedly activates your neurons and makes you learn. These changes happen as early as when a baby is in their mother's womb and continues throughout a person's life. So, the question is, how can you help your neurons to create and strengthen their connections? Here, we present two strategies that appear to be more compatible with how your brain works and could help you learn better. Which learning strategies are more compatible with your brain? Strategy 1. Repeatedly activating your neurons. Practicing a lot, trying to retrieve information from your memory, for example by explaining a concept to a friend or answering quiz questions. Because the connections between your neurons need to be activated multiple times to become stronger and more efficient, a first and crucial strategy is to repeatedly activate them. This means that to learn arithmetic tables, for instance, you have to practice it repeatedly, to establish the trail between your neurons. As a baby, you were not able to speak and walk within one day, you practiced a lot. However, it is important to note that only reading or glancing at your arithmetic tables will not be that helpful in connecting your neurons. You might also find it quite disengaging and boring. To create the connections between your neurons, you need to retrieve the arithmetic tables from your memory. In other words, you have to recall the answer yourself to activate your connections. We are not saying that this is easy to do. However, scientists think that this struggle improves learning because the challenge is an indication that you are building new connections. Remember, learning something new is like hiking in a bush with no designated trail. You will probably walk slowly at first, but if you keep hiking, trails will start forming and eventually you will be walking on well-beaten tracks. Besides, when you do try to recall what you have learned and make a mistake, it can help you identify gaps in your learning and give you an indication of which trail still needs to be worked on. Scientists have also noted that performing tests or exams can help you remember information better than studying alone. For example, if you study your arithmetic tables interspersed with test periods, you will probably perform better on your final test than if you had only studied. Why? The tests require that you retrieve the information from the neurons in which the information is stored, thus activating your connections and contributing to their strengthening. The point is thus to practice retrieval in an engaging way. There are different strategies that you could try at home, for example answering practice questions or using flashcards. These should improve learning more than rereading or listening to lectures, as long as you do not flip the flashcard over before recalling the answer. Other strategies include preparing questions to ask to a classmate or a parent as well as redoing tests or exercises. Use your imagination. What you need to remember is that first, for your neurons to strengthen their connections, you need to retrieve the information and avoid just reading or listening to the answer. Second, you should plan a way to get feedback to know whether you got something correct or incorrect. Do not be discouraged if you face challenges. This is a natural step of the learning process taking place in your brain. Strategy 2. Spacing the activation of neurons, practicing more often but for a shorter period. For example, instead of studying for 2h in a row, studying 4 periods of 30 minutes over a few days allows your brain to take breaks and sleep, which helps you remember better in the long run. Now that you know that neurons need to be activated repeatedly for learning to occur, and that it means retrieving information, you probably wonder how often you should practice. Scientists who study the learning brain observe that breaks and sleep between learning periods enhance learning and minimize forgetting. It therefore seems better to retrieve often within spaced practice sessions, as opposed to a massed practice, practicing a task continuously without rest. For instance, instead of studying or doing homework for 3h, after which you would probably feel exhausted anyway, you could separate this learning period into 3 1h periods or even into 6 half-an-hour periods. In short, when spacing your retrieval practice, you allow your brain to make the connections that you strengthened during your practice sessions more efficient. When you take a quick break from practicing, let us say a 20-minute recess, you allow for the maintenance or replacement of the receptors on the surface of the neurons. The receptors are like electric outlets that receive the nerve impulse, electrical signals, from other neurons. Taking a break helps them work better. Your neurons can thus transmit their nerve impulses more easily to other neurons. Finally, when you get a night of sleep between practice sessions, you actually benefit from a free retrieval practice session because while you sleep, your brain reactivates the connections between the neurons that you activated during the day. You could also get similar benefits from a nap. Next time you find yourself sleepy in class, you could tell your teacher that you are in fact trying to do retrieval practice. In brief, when spacing out learning, and especially retrieval practice, your brain is more activated than when you mass learn in one long session. At this point, you are probably asking yourself how to space out learning in your day-to-day life. The good news is that there are a number of ways to do it, and it can be easily adapted to different skills, such as solving mathematical problems or memorizing definitions. The most obvious change you can make to your study schedule is to break up sessions into smaller sessions. You could also ask your teacher to set daily or weekly review quizzes and other assignments. Finally, spacing can be done by doing interleaved practice. This consists of a set of problems arranged so that consecutive problems cannot be solved by the same strategy. For example, you could mix your math problems so that geometry questions, algebra, or inequality problems are randomly sequenced. The added benefit of interleaving is that you engage in different activities in between 2 sessions, making good use of your time. In brief, one thing to keep in mind is that information that was previously learned will require less effort to relearn because the spacing gives your brain time to consolidate, meaning your brain produces the building blocks required for the connections between your neurons. Conclusion. Your brain is where learning occurs, and you therefore need to keep your neurons active to optimize the use of class or study time. The 2 learning strategies proposed in this article have the potential to help you learn better by creating optimal conditions to strengthen and consolidate the connections between your neurons. You now know that you can get better by repeatedly using the trails in your brain and by spacing out your practice. This greater understanding of how your brain learns and the use of supportive learning strategies can now allow you to help your brain learn better.